Alright, you geniuses, we're going to do some consolidation work today. Let's see how we get on with this. The first questions here from section 1, we are trying to find both the area and the perimeter of these shapes. So I'm going to start with working out the area for B. 1B I think it is. And I can see that I have a rectangular shape from which I've cut out two half circles. So it's going to be, the area is going to be 40 times 35, which is my rectangle. Take away pi times my radius squared. Now this is diameter, so my radius must be half of that, which I think is 17.5. Now when I chuck this together in my calculator, what do I get? Well, to three significant figures, I'm getting 438. Okay. Now, the perimeter. You can see that this bit here is 40 and this bit is 40. So we're going to have 80. And then you can see that we've got this bit, let's do this in a different color perhaps. We've got this bit here, which is a half circle, and this bit here, which is a half circle. So it's going to be plus pi d, which is circumference, pi times d, which is 35. Now if we chuck that all together, what do we get? We get 80 plus 35 pi, and I'm getting 190 to three significant figures. Now this next one. Okay, we're going to do C. We want the area. The area is equal to the square, so you can see we've got a square, 7 by 7, yeah, so 49. Take away, now you can see that this is a 90-degree angle here, so this is a quarter of a circle, 1/4 times pi. Now the radius, this bit here, is 3.5. Why is it 3.5? 0.5, 0.5, 0.5, 0.5, 0.5, Now when we chuck this into our calculator, what do we get? 21. I'm getting 26.5. For part E, the area of this is going to be, now we've got almost a whole circle. The fraction we've got is 300 out of 360 degrees, and we're going to times it by pi r squared, and r is 4 in this case. Now what does this give us? When we chuck this, we get to three significant figures 41.9 centimeters squared. Now for the perimeter, it's made up of a couple of bits. You see we've got this bit here which is 4 and this bit here which is 4, so it's going to be equal to 8. Then you can also see, I hope, that we've got this bit here which is circumference of a circle. So it's going to be 300 over 360 times pi times d, and d in this case is 8 since r is 4. Now, when we chuck that into the calculator, what do we get? 8 times pi times... Now, I'm getting, hopefully I haven't made a silly error here, but I'm getting 28.9 centimeters. Okay, now let's move over here and see what we can make of these questions. For the next one, we've got the end face of a prism of length 10 is a right angled triangle with 4 and 5. Now I probably want to change this. I'm going to draw it 3D a bit more, so I might go like this. Very bad drawing. That's my prism. And now I'm going to find the volume. The volume is going to be the area, so this bit here, half times 3 times 4 times, and it's not 5, right? A 3, 4, 5 triangle is like this. You've got a right angle there, so that's your base, that's your height. And then we're going to times it by this 10. And this gets us 2 times 3 is 6 times 10. 60 centimeters cubed. Now, for number 4, we have a pond, and the area of the pond is equal to pi times r squared. Now, r in this case is half of 9, so that's 4.5 squared. And so we can go 4.5 squared times pi gives us 63.6. I'm going to save my unrounded number there, centimeters squared. Now for B, the pond and the path together. You notice we've got 1.5 here, which means we've got 1.5 here. So in total, the whole thing across is 12. Okay, 9 plus 3 is 12. So the area in this case is going to be pi times the radius squared, and now the radius is 6. So this will give us 36 pi, which is 113. Okay, centimeters squared. Now, what we want to do is just find the area of the path. So what we'll do is we're going to take this one and subtract this from it. So the area will be the 36 pi subtract the 63.6, whatever it was that we had, and we should get 49.5-ish centimeters squared. Okay. Now, number 5, we're trying to find the volume in the surface area. So, let's see. Hopefully you've got enough room for this. The volume is quite easy. So for number 5, the volume is equal to the area of this triangle here, right? Which is half times 6 times 7 times the length here, which is 12. Now, when we chuck this into our calculator, we get 3 times 7 times 20 times 12. So I get 252. I hope that's right. 252 centimeters squared. Now, cubed. Okay, now let us find the surface area. So B, the surface area. So you can see we've got this triangle here. And we've got 2 of them. So 2 times 1/2 times 6 times 7. And that will give us, what was that, 21, I think? Oh, it's 42. Sorry, 42. Okay. And then we need to do the bottom. Okay, and the bottom is 6 times 12 is 72. And then we need to do this side here. Up there, which is the left hand side, so that looks to me to be 7 by 12. is that 84? I think it's 84. And then finally, we need to do this front right-hand side, which you can see is 9.2 by 12. No, I don't know, 9.2 times 12. 552 over 5, so 110.4. And then to find the total, we've just got to add them all up for the total surface area. SA should be equal to, add all of these ones up. What does that give us? 42 plus 72 plus 84 plus 110.4, which is 308.4 centimeters squared. Okay, let's move on. We've got a few more questions to do. Give ourselves a bit of room for each of these. Okay, number 10. What do we need to do? We've got some cylindrical jars. They've got a diameter 16, height of 28, and they can be filled from a cylindrical vessel, diameter 16, height. Okay, so we want to find the volume of the jars. Volume jar equals pi times r squared, which in this case is 8, times the height. And this will give us I'm going to leave it in pi, 1792 pi centimeters squared. That's the jar. Now we're going to find the volume of the vessel. Presuming this is like some kind of big pot sort of thing. Pi times, now its radius is 30 because we want to halve that number there, times its height of 40. What does this give us? 36,000 pi. Now, number that we can fill. So we're going to go 36,000 pi divided by that 1792 pi, and that will tell us how many vessels we can fill. And it looks to me to be 20. You round down because if you haven't filled the vessel, if you filled 0.8 of a vessel, you actually haven't filled it. Okay, so just think logically about that. Okay, this we've got to find the volume of this shed. Now I'm going to tell you something really cool. A trapezium is a shape like this, where you've got oh dear, what a debacle, sorry. A trapezium is a shape where you've got two parallel sides, a four-sided shape. Okay, we call this the two parallel ones A and B. The perpendicular distance between them is called the height. And the area of a trapezium is equal to half, bracket, A plus B times the height. Now, here you've got your two parallel sides, okay? So the area of that front bit there is going to be 2.5, so half A, which is the 2.5. It's a bit messy, let's just fix that up, 2.5, plus the 3, and then times the height, which is, I know it doesn't look like a height, but it is the perpendicular distance between those two parallel sides, so it's times the 2. And this gives us 5.5. Oops, that's messy. 5.5. So now the volume is therefore going to be 5.5, the area of the front face, this bit here that we've just worked out, multiplied by the 6.5 here. Now, some of you may have done it another way. You may have cut things into triangles and rectangles, and that's fine, but sometimes knowing the trapezium formula is going to make your life a little bit easier. Now, let's have a look at number 15. We know that the room is 3 meters high and has a volume of 45, and we've got to calculate the surface area of the floor. So here's our room. Okay, excuse the bad diagram. Okay, what we're trying to find is this area here, because we know the height of the room is 3 and we know the volume is 45. So we know that 45 is equal to 3 times the floor area. So that means that 15 is equal to the area of the floor, because I've just divided both sides by 3. Part B. Now a dormitory is 10 by 6 by 3, so that means the volume is 60 times 3, 10 times 6 times 3, which is 180 meters cubed. And we know each person needs 18 meters cubed of airspace. Therefore, how many people can we have? We go 180 divided by 18 equals 10 people. So this last one, we've got the hand of an hour clock, and we're trying to find out how far it passes, area it passes over in 3 hours. So let's just imagine we start at 12 o'clock. We're talking about the hour hand. The first time I did this, I wasn't paying attention and assumed we're talking about the minute hand. And it moves in 3 hours. It's going to move to 3 o'clock. So you can see that it's moved a quarter of a circle. Okay, and the hand is obviously its radius. So the area is going to be equal to 1/4 times pi times 10 squared, and this will give us 25 pi, which gives us 78.5 centimeters squared in 3 hours. And that's that. Well, if you have any questions with these guys, as always, let me know on ThinkWave.